Namaste children. Hope you all are staying home and staying safe. Don't worry, we will come out of this COVID-19 crisis very soon and we will come out very successful because the leader of the nation and the leaders of the states are working really hard along with the defense, the medical fraternity, paramedical fraternity, the police and many other forces in our society are working day in and day out to walk us through this crisis successfully. Don't you think we all should be worth their hard work and sacrifice? Yes. How do we become worth their sacrifice? It's possible only if we do our duty. If we spend our time productively during this lockdown by doing our duty, then we will be worth their hard work and the sacrifice. So children, I will be posting a few videos of a few lessons to make up for this lockdown period. Please concentrate on studies for a few minutes per day so that you don't feel the burden of the academics, burden of the syllabus once the academic year restarts. So shall we begin? Yes. So I will be beginning with polynomials. Polynomials. What are polynomials? You have already been introduced to polynomials in your earlier classes. Just a quick relook into what polynomials are. Polynomials are algebraic expressions. Algebraic expressions with certain conditions. And the definition of polynomials gives us the condition. The algebraic expression which have these components. The components are variables, constant and exponent. Variables, constant and exponents. And the four basic operations involving all this. Four basic mathematical operations like addition, subtraction, multiplication and division. So let's see this 5x plus 3 is a polynomial because we have a constant and a variable with coefficient. So let's take coefficient also. Coefficient can be any number. And then we have 7x square plus 5x plus 8. This is also a polynomial. These are the components of algebraic expression which polynomials have. The strict condition for the algebraic expressions to be, yes, there are certain conditions. They are involving the variables and its power. Power or the exponent of the variable should be a non-negative number. Should be a non-negative number. What does this mean? This means it cannot be a negative integer and it should also not be a fraction. The exponent should not be a negative or fraction. What does that mean? Now let us say in this polynomial 1 by x plus 9x square. In this is a non-negative number, this is a positive number. But if you write this in the exponential form, this becomes x raised to minus 1 plus 9x square. But this is minus 1 here. So what does it say? It should not be a negative. So this is a negative. So this is not a polynomial. And then we can consider another polynomial, root x plus 11x cube plus 9. What about this polynomial? Now let us express this also in exponential form. It becomes x raised to half plus 11x cube plus 9. See now the exponent is in the fraction form. So this is also not a polynomial. And there's another form that you need to be very careful about. Variable should not be in the denominator of the term. Variable should not be in the denominator of any term. For example, we have already seen one example. 3 by x plus 2 plus 7x cube plus 9x. Here the variable is in the denominator. So this is also not a polynomial. So polynomials will have components like variables, x, right, constant, as in case of this polynomial it is 8, and then we have exponent, the power, which is 2 in this case, and then coefficients, like we have 7 is coefficient of x square, 5 is a coefficient of x. This actually has a variable but in this form, and polynomial usually are arranged in such a form that the power is in decreasing order. Not necessarily, but it is normally expressed in decreasing order. So this is x raised to 1, x raised to 0, but we don't write this every time. It is 8. Why we have to understand this is to know that if just a number like this is given, this is also a polynomial. This is also a polynomial because this is actually 9 times x raised to 0. So this is also a polynomial because the definition of polynomial holds good in this. The definition of polynomial says the variable should be there and the power of the variable should be a non-negative number which is 0, 1, 2 and so on, which is 0 in this case. So just a number is also a polynomial. Now let us understand what is meant by degree of polynomial. Let us consider this equation 3x plus 5, and let us consider this equation 7x square plus 8x plus 9, and let's consider 27x cube plus 11x plus 24. If you observe these, you will understand here the power of x here is 1 and here the power of x is 2, 1, right? And what is the highest power in this? It 1. What is the highest power in this? It is 2. What is the highest power in this polynomial? It is 3. Now, 3 here, 1 is the degree of this polynomial. The highest power is considered and that number is given as degree of the polynomial. Here 1 is the degree of polynomial. Here since 2 is the highest power, 2 is the degree of polynomial. Here 3 is the degree of polynomial. And this is called linear polynomial. This is called quadratic polynomial. And degree of 3 is called cubic polynomial. And there are many more after this which we don't study in 10th standard. We don't require. Polynomials can be categorized on two bases. One is based on the number of terms. Based on the number of terms. And another categorization is based on the power or the exponent. What value the exponent has? The highest power. The highest power of the polynomial. Now, how is it categorized based on the number of terms? If a polynomial has just one term, let us say 7x, or it could just be 5. This is also a polynomial. Here we are considering the variable to be x raised to 0. X raised to 0 means 1. Anything raised to 0 is 1. So this is 1. So 5 times 1 is 5. So this also can be considered as a polynomial because variable is there and the exponent is in the form of a non-negative number. So the definition of polynomial holds good here. So this is also a polynomial. So we every time don't write like this. We only write it as just this number. What we say as constant. Just with a constant also, it is still an algebraic expression and can be called polynomial. Yes, and then if you can just have 6x cube. Now these are all just one term in the polynomial. So polynomial with one term like this, just one term is called monomial. And then similarly, two terms is called binomial. And anything more than that, we don't go on giving names for your convenience. We just call them polynomials. Many terms, polynomials. Now, based on the highest power, we have, let us say we have 3x plus 8. And we have this expression 11x squared plus 3x plus 5. I'll tell you what these are. And then if we just have 15x cube plus 4x squared plus 3x plus 11. Now you see the differences in these polynomials now. There's only one variable here, x, and what is the power of this? What is the exponent of this? 1, right? So when this has 1 as its exponent, the highest exponent itself is 1. Such a polynomial is called linear polynomial. And then when the highest power, now this is 2 and this is 1, which is the highest in this? Yes, 2 is the highest. So when this is 2, it is called quadratic polynomial. Quadratic polynomial. And when a polynomial's highest degree or highest exponent itself is called, is 3, then this polynomial becomes cubic polynomial. It is called cubic polynomial. Now, the polynomial which has the highest degree as 1, highest exponent is 1, then degree of this polynomial is said to be 1. So, what is the degree of this polynomial? Degree, now this is a type, and what is the degree? We call the highest exponent of this polynomial as degree of polynomial. So, what is the degree of this polynomial? 1. What is the degree of this polynomial? 2. What is the degree of this polynomial? 3. Degree of this polynomial is 3. Beyond this we have quadrinomials, quintinomials, and we don't deal with all these things in class 10th. So we are only concentrating on these 3 types of polynomials, and we go up to degree 3 polynomial. Yes? So, and these degrees of polynomial have got to do with zeros of polynomial. Now, what are the zeros of polynomial? Now we will see zeros of polynomial. A quick look into the zero of polynomial, which you have already discussed in your previous classes. Zero of polynomial means value of x, such a value of x when substituted in the polynomial, the value of the polynomial becomes 0. Now let us try to understand by taking this example. Now let us say 3x plus 8. Now let's go on substituting some value. Now this is p of x. We write it as p of x is equal to 3x plus 8. When x is equal to 0, we write this as p of 0. Let's see what happens to the value of the polynomial. P of 0 will make the polynomial 0 plus 8, this is 8. Right? Similarly, let's see what happens to p of 1. 3 times 1 plus 8, which is 11. Yes, at this value p of minus 8 by 3. Let's see what happens to this equation, which is 3 minus 8 by 3 plus 8. This becomes 0. Yes. So now p of minus 8 by 3 is 0, which means to say when x is equal to minus 8 by 3, the value of the polynomial becomes 0. Now, this value which is making the polynomial 0 is called 0 of the polynomial. 0 of the polynomial. Like this, when we find such values of x which make the value of the polynomial 0, it becomes 0 of the polynomial. Now in this expression, how did we calculate the 0 of the polynomial? It's very easy to find the zeros of the polynomials. Yes. 3x plus 8. We know very well that the value of this should be 0. So 3x is equal to minus 8. X is equal to minus 8 by 3. Right? So now this is the 0 of the polynomial. Since it is a linear polynomial, this polynomial, all the linear polynomials will have only maximum 1 0. It can have only 1 0. When we say maximum, it can be less than that also. So anything less than 1 is nothing but 0. That means there can be a polynomial which does not have a 0 at all. No zeros at all. That means there can be no value which can make the polynomial 0. So, linear polynomials will have 1, 0 maximum. Similarly, you must have seen in your earlier classes that quadratic polynomials. How we can find zeros of quadratic polynomial. Now let us take example of this quadratic polynomial. So we use splitting the middle term, or it is called factorization. So when we factorize, we have right. So you will have gone through all these things in your earlier classes, but I am just showing. Right, x minus 4 equals 0, x plus 1 equals 0, x is equal to minus 1, x minus 4 is equal to 0, x is equal to 4. So now x has got two values. When you put them back in this equation becomes, when you either you put minus 1 or you substitute x by 4, the polynomial becomes 0. Now, shall we just see that quickly? First, I will take minus 1, x square minus 3x minus 4. Minus 1 square minus 4. 1 plus 3 equals 4. Sorry, 0. 4 minus 4 equals 0. It became 0. So, minus 1 is 0 of the polynomial. Now, let us take x is equal to 4. So, we will substitute directly 4 square minus 3 times 4. So, this is 16 minus 12 minus 4 equals 0. 16 minus 16 equals 0. It became 0. So, now minus 1 and 4 are the zeros of this quadratic polynomial. So now, in the quadratic polynomial whose degree is 0, we get maximum 2 zeros. Maximum 2 zeros. When I say maximum 2 zeros, how many zeros it can have then? It can be no 0, 1 0, 2 zeros. All the three cases are possible in a quadratic polynomial. Now let's take an example of, now let us keep these two values somewhere. Ready? I'll just keep these values here. X is equal to minus 1, x is equal to 4. So I'll remove the remaining part so that we can see an example of a cubic polynomial also. Let's take this equation, a simple equation. This is also cubic polynomial because the highest exponent here is 3. So this is a cubic polynomial. Now let's try to find zeros of this. Take x common, right? Like how we generally do. X square you are left with minus 4 equals 0. And it becomes x square minus 4 is equal to 0. Yes. How could I write this? Because this x, when it is transposed to right hand side, the right hand side becomes 0. Something like this. If anybody has difficulty in understanding, let me just quickly show. Because this is for all the level learners that I am trying to reach. Right? So this becomes 0 now. So considering this, but we don't have to do this every time, not necessary. So we write like this, and then x square is equal to 4. I am transposing 4 to RHS. X is equal to plus or minus root 4. X is equal to plus or minus 2. Which means we have two values here. One is x is equal to 2. The other is x is equal to minus 2. when you substitute these two values here, it becomes, the polynomial becomes 0. Whether it's p of plus 2 or p of minus 2, this polynomial becomes 0. So these two are zeros of polynomial. Here for this equation we got only 2. But for a polynomial whose degree is 3, maximum we can get, maximum we can get 3 zeros. Which means to say it can be no 0, 1 0, 2 zeros and 3 zeros. Right? So 4 possibilities are there for a cubic polynomial. Now the next thing is very interesting. These zeros have got something to do with the graph. Which means when these equations are plotted on a Cartesian plane, we get a certain pattern graph, certain pattern lines. Okay. Now you have already plotted linear polynomials in your earlier classes. As the name itself says, right? What is it here in this? Line, right? So if you can recall, linear polynomials when plotted on Cartesian plane, you will get a straight line. But it's not the same with quadratic and cubic polynomials. Anyway, plotting of quadratic and cubic polynomials is not a part of your syllabus of class 10, but you just still need to know pictorially how it comes. I'll show you how it comes. Now let us see. Yes. Now this is a Cartesian plane. Now let's see and show you how a graph comes when a quadratic polynomial is plotted on a Cartesian plane. It will be a curved line like this. A curved line like this, which is called parabola. A curved line is called parabola. Okay? Now, when any quadratic polynomial is plotted on a Cartesian plane, we get in different conditions will be there. So I'll just show you and how this can, just by looking at the graph, we can say whether the polynomial has a 0, 1 or 2 zeros. Now let us say if the polynomial is something like this, right? See now this particular graph, this particular parabola is touching x-axis. Now when we solve for x, what did we get, children? Minus 1 and plus 4, right? Which means when this is plotted on a graph, so one side it will be like this and the other side it will come like this, which will be plus 4, right? So if you have plus 4 here, let us say this is 4 here. So the equation which we solved just now, when plotted on a Cartesian plane, we will get something like this. Means this graph of that equation is touching x-axis at minus 1 and plus 4. It will come like this. So which means to say the graph, wherever it intersects x-axis, that will be the zero of the polynomial. For example, if there is any polynomial which is intersecting x-axis like this, it can be. So, what are the zeros of the polynomial? Minus 3, minus 1. Right? And then, let us say something like this can be possible. So, what are the zeros of such a polynomial, such a quadratic equation? 0 and 3. Here 0 is also a 0 of the polynomial. 3 is also a 0 of the polynomial. Right? And then we can also get something like this. So what are the zeros of such polynomials now? This graph is intersecting plus 1 plus 3. So the zeros of this graph can be 1 and 3. That means x is equal to 1, x is equal to 3. Right? Yes. So all good. Then what happens if it is here? If it comes like this, it is not touching x-axis anywhere. You see? Not touching x-axis, which means no zeros. No zeros of the polynomial. Similarly, it can be downward also. This also will say no zeros of the polynomial. Now what happens? We have something like this. Yes, we do have. We have solved many quadratic equations where we got x is equal to 2 and x is equal to 2. Same values will be there. That means 1, 0. Both the zeros are coinciding and coming here. 2. 2 is the 0 of the polynomial. But there is only 1 0 which is 2. They are coinciding. Is it clear? So, now a quick review. If it is like this, we can say 2 zeros, and if it is like this, it is 1 0. It is like this again 2 zeros which are both positive values, and if it is somewhere like this, no zeros at all. Right? This is with a quadratic polynomial. This is called parabola. A curved line is called parabola. Similarly, when we plot a cubic polynomial on a Cartesian plane, we get like this. The curve is like this. For quadratic we had only one. For cubic we will have two like this. You see? Right? So it is touching x-axis in 3 places. Right? So one is -3, 0 and +3. Right? So when it is like this, so wherever in how many places the curve is touching x-axis, you should see this. You should see that. Then that many zeros this polynomial will have. Now this curve is touching x-axis in 3 points at 3 places, so it has 3 zeros. Then what about, it could be something like just now we solved one problem, right? We got two values, -1 and 2. Sorry, -2 and +2. We got -2 and +2. So it can be like this. It may not even touch. So this will be 2 zeros for that polynomial, but it is a cubic polynomial. It will have a curve somewhere ending like this. It can be something like this. You don't really have to worry about the shape. You just have to know that in how many other places it touches. So what happens if it is touching like this? Then how many places is this curve touching? In only one place, which is +2. Right? So how many zeros, children? 1 0. How many zeros? It is touching in 3 points, the x-axis. Then it is 3 zeros. What about this? No zeros. Because the curve is not touching x-axis at any point. So, no zeros. So, we saw no zeros. It can be 1 0. Right? 1 0 like this. And it can be 2 zeros like this. And 3 zeros like this. Right? So, the curve or the line that we plot on Cartesian plane, you should see in how many places it touches x-axis, then that many zeros the polynomial will